So welcome to AP Environmental Science, Chapter 16. This is the chapter on the oceans, basically, marine ecosystems. Let's begin. Well, your central case in your book talks about the collapse of the cod fisheries in the northeastern United States and Canada. Well, what happened? Well, back in the 1800s, early 1900s, people would show up and were immigrating to the United States and Canada. People show up in this area here was a very, very lucrative cod fishery. Cod is a ground fish, meaning it resides towards the bottom. What did they do? Well, they over-harvested it. They fished it to the point of collapsing it. Apparently, at one point, there was so much fish there that you could just cruise a boat through and fish would actually jump into your boat. There was that much fish there. That was what was said originally. But now you go there and it's not quite like that. Now you're going to have to try quite a bit harder to catch these fish. So what is the cause of that? Well, technology, larger ships, more vessels, more commercial fishing, over harvesting and taking out more than can recover, basically. All right. So that's what happened in the fisheries. The ocean. Well, the ocean, about a little over 70%, 71% of the earth is covered by ocean. 97.5% of the water on our planet is salty. The oceans influence so many things on our planets. In case you don't know the oceans, the Pacific, the Atlantic, the Indian, the Arctic, and the Southern Arctic Ocean. Those are the oceans in case you don't know them. The oceans on our planet, the largest, Pacific, they say you can take all the land on the earth and it'll all fit in the Pacific. The Pacific also has the deepest point, all right? The Indian is the warmest. Why is it the warmest? Because it is equatorial, so the water is generally a little warmer there. So what does the ocean do? Well, it influences climate. It moves heat around our planet, okay, or moves the lack of heat around our planet, and it facilitates climate control that way. We use the oceans for transportation, for movement, commerce, resources, a lot of things. The ocean is a big deal. We are called the blue planet for a reason. So here's some terminology. This is a typical oceanic or oceanography. This is the structural features of the ocean. When you enter the water, if you're at a beach, you're entering the continental shelf. Then it hits a point where it starts to slope more. That point is the slope break, where it begins to slope more drastically. That's the continental slope. Then you hit a region called the continental rise. Ridges or ocean ridges or the mid-ocean ridge, that's where you have underwater mountain ranges. You have the accumulation of sediments. They build up because these currents move these sediments. This is eroded or weathered rock matter. A trench is an area where you have a plate, two plates smashing into each other, and then they're dipping below each other. That's a trench. That's when that occurs. All right. Island arcs. These occur where you have a oceanic plate dipping below a crustal plate, and you have these island arcs form up, and they're volcanic islands that show up in these regions. Okay. Well, what happens? Well, physical features. Okay, so oceanographic, or features on the ocean bottom. Okay, so like a ridge area or different features, structural features that occur. These are areas teeming with life. Why? Wherever there is more habitat created, those areas generally have more underwater life. So when you have a ship, for example, that sinks, that area all of a sudden starts teeming with life. Even a ship that sinks, well, that ship has a lot of caverns and different nooks, and those areas become places for shelter for different organisms. And then other organisms end up coming because they feed on them, so it brings more and more organisms to the area. All right. So 96.5%, a lot of these percentages, that percent of the water, that's how, like if you look at ocean water, 96.5% of ocean water is water. 3.5% of it is these different salts. And what are these salts made out of? They're not always sodium. There's magnesium chlorides and sulfates, calcium chlorides and sulfates, potassium chlorides and sulfates, bicarbonate is in the water. That's the way most of the carbon dioxide is stored in the water, stored as bicarbonate. You have some sodium. So it tastes very salty because all these things, technically, if you connect them to other things and create salts out of them, they will all taste salty. So salt. It varies. So how salty the water is determined by where you're at. So if you're at the equator, if you're looking at a map of the Earth, and the equator, right down in the middle of the Earth, that's where you have the most sun exposure, which means you have the highest amount. And by the way, you have the most evaporation, but you also have even more so precipitation. So they have a lot of precipitation in the equator regions or equatorial regions. So much precipitation that it basically dilutes the water in those areas. So water near the equator is a little less salty. 30 degrees north is right around where we are in San Diego. So 30 degrees north is or south is generally where you'll see deserts, drier areas, less rain. So in those areas, there's more evaporation and less precipitation. Think of San Diego. We don't get a lot of rain. We have generally dry weather most of the year. So the areas of oceanic areas around 30 to 35 degrees north and south have more salt in the water because of how much less evaporation. Excuse me, more evaporation compared to less precipitation. So that's what happens around 30 to 35 degrees north and south latitude. Waters near coastlines, well, they get an influx of fresh water that is runoff water. So coastal areas generally have a little less salt also. Nutrients that you find in seawater, you find nitrogen and phosphorus. They're not always nitrogen and phosphorus. Most of the time they're dissolved. They're nitrates and phosphates. What you need to know is nitrogen and phosphorus. Nitrates and phosphates are going to be, for the most part, the same thing in regards to the nutrients that are found in seawater. A lot of the gas that is found in seawater is oxygen. Where does the oxygen come from? It comes from the organisms that are doing photosynthesis. The different kinds of algae in the water, the plankton and the kelp. Plants, there's photosynthetic plants that are in the ocean, and there's photosynthetic bacteria that is also producing oxygen. Carbon dioxide is also a dissolved gas found in the ocean. And carbon dioxide, where does it come from? All the organisms in the ocean are producing it when they do cellular respiration. What does it do? It makes water more acidic. And when water becomes acidic, the pH drops. Now, the ocean is on average about an 8.1 pH. It never becomes an acidic pH. It never goes below 7, just so you know. The pH might decrease, but it doesn't go below 7, all right? Solar energy, well, the top layer, the top 2%, well, the top layer of water that receives the sunlight, that's the area, that's about 2% of the ocean, okay? So about 2% of the ocean is getting sunlight, right? So what does the sun do? Well, it heats the surface. Living things are up there because that's where you're going to have photosynthesis taking place. So fish and other organisms are going to be where photosynthesis is taking place. Cold, saltier water is denser, so it sinks, it drops. Water at the surface is warmer and less salty. Water that is below is colder and saltier. And why does it sink? Because it's denser. All right, so it drops, it sinks. So there's currents aren't just sideways, horizontal currents can be vertical, not north, but up and down. Okay. The pinocline, this is the area basically where it gets very dense very quickly. This is below the surface layer, so this makes up 18% of the ocean layer. The surface layer is about 2%. Below that is the pinocline, it's about 18%. So it gets very dense very quickly. Below the pinocline, 80% of the water resides below that point. And what's happening there, you don't have a lot of effects of sun and wind. Why? Because it's so deep. The sun and the winds and storms, temperature fluctuations, you don't have a lot of that affecting it down there. San Diego, for example, has and I'm talking about coastal San Diego, generally stays very mild all year. If you live on the coastline in San Diego, it generally never gets colder than around 55 at the beach. And it generally never gets warmer. The warmest it gets is in the 90s. All right. Comparing that to here where we go to school, Valhalla, it gets in the wintertime, it gets in the 30s. And it will get in the summertime, I don't know, 110, 112. We've had it here in this area here in Rancho San Diego, where the beach doesn't get 110. Never. The beach never gets 30, ever, even the coldest. That's because the water on our coastline stays a fairly neutral temperature. San Diego's coldest days in the ocean are in the 50s, and our warmest days are in the 70s. So San Diego generally has a moderate climate all year because one of the reasons is that large body of water near us and its ability to retain heat very well, or it has a very high heat capacity. Okay, so that means it takes a lot of energy to change the temperature of water. So even when it's 100 degrees out, that's not enough energy to change the temperature of the water very much. All right. Currents. Well, movement of water. This shows you a map showing you all these currents, all this water movement. There's surface currents, there's deeper currents, there's horizontal currents, there's vertical currents. So water is in motion constantly. Or let me go back. What drives currents? Well, anything that moves water is going to drive a current. Differences in density, horizontal, vertical, heating and cooling, makes water move, creates convection currents. Gravity pulls on the water, moves it. This is what tides move the water. Wind, for example, moves the surface water. Okay. Now, upwellings. What is an upwelling? Well, sometimes you have regions where winds will push water. And when they move water away from a region, that water sometimes gets filled in by what's called water that comes from below, or an upwelling. Where do upwellings occur? Well, when wind blows down a coastline, parallel to a coastline. In this case, it's showing you north to south, but that doesn't matter. As long as it's parallel to a coastline, okay, it moves the water, and then an upwelling will fill in that water. Or when water diverges or moves away from a coastline, an upwelling will take place. Why are upwellings important? Upwellings are areas where you have lucrative fisheries. With an upwelling, nutrients come up, and when nutrients come up, you're going to have more algae, you're going to have more fish that feed on those algae, and then you're going to have a lucrative fishing area in an area of an upwelling. The opposite of an upwelling is a downwelling. This happens where currents converge or go at each other, or winds blow water towards a coastline. This causes water to shift and go down, and as it goes down, it takes nutrients down with it. Okay? So, for example, oxygen and other nutrients will go down. Downwellings are not areas that fish want to reside because there's less nutrients in those areas. Thermohaline circulation. So heat, and in this case, haline, salt. Heat and salt drive, so warmer, lower salinity. So warm temperatures and salt will drive the movement of water around our planet. This is showing you, look at this. So heat's getting picked up. This is the United States. This is up here, Alaska. The water picks up heat, starts moving along the planet. And you'll see this warm surface current moving along the planet. And then this is now the Atlantic Ocean. So it's moving north in the Atlantic Ocean. And it gets up here towards Europe, and then it loses its heat. All right. And this heat is used to help warm part of Europe. Otherwise, they say Europe would be a colder place if it wasn't due to this current dropping its heat off. So as it drops its heat off, okay, that water gets colder. And colder water will now sink. That sinking creates what's called the North Atlantic deep water. So this is a region of downwelling over here in the North Atlantic. And why? Water sinks because it gets cold right there. Right? So it's a deep region where there's a downwelling due to the water getting very cold all of a sudden. El Nino. Being in San Diego, we hear of these a lot. Why do we hear about? Because we are a coastal community. We are indirectly affected by it. Why? We are not equatorial, but we're 30 degrees north of the equator. So we are going to be affected by it. So look at this map here. So this little dotted line, that's the equator right there. That little dotted white line is the equator. We're up here. We're just a little bit north of it. So we are indirectly affected by an El Nino occurrence. It's called ENSO, or the El Niño-Southern Oscillation. So let's look at normal conditions and compare them to El Nino conditions. I got to give you a little background to make some sense out of the concept of El Nino. All right. And just so you know, the reason it was called El Nino, I believe a bunch of fishermen, they discovered that the water got abnormally warm one winter, and it was during Christmas time, and the Son of God, they call it El Nino, in Spanish, so they called that occurrence an El Nino. And it was a bad thing for them because when the water got warmer that year, the fishing wasn't as good, and I'll explain to you all that happened the year they really noticed it and gave it a name. So if you look at this picture, here's the ocean, here's the Earth. You got the equator right down the middle. So we're talking about an equatorial region, okay? So San Diego is on the edge of this region of where El Nino is affected. So you need to know that wind generally moves from a high pressure area to a low pressure area. So there's some importance here. You need to understand about wind movement. So winds move from high pressure to low pressure. And then the wind is going to be moving water, and that's why it's in the ocean chapter. Okay, so winds, showing you the surface winds. They're moving from here to here. Okay, the winds are moving from here to here. In this case, right to left on this map here. All right, and this is the Pacific, in case you didn't know where we were, the Pacific Ocean. All right, so this is the U.S., this is the Pacific, and you need to know where things are. You have Indonesia over here, and you have Australia over here, clear on the other side. Okay, so you have all the way over here, Australia and Indonesia. All right, so you pretty much got the other side of the planet going on over here. So what happens? Well, winds move from a high pressure here, and remember, this is the Eastern Pacific, this is Western Pacific. So in the Eastern Pacific, which is where we are located, Eastern Pacific, you have a high pressure system naturally moving winds towards a low pressure area over here in the Western Pacific. So winds move from a high to a low naturally. And as it does that, it moves water with it from the, like I said here, the Eastern Pacific towards the Western Pacific. Well, that creates a natural upwelling. So water is moving away from a coastline, and that creates upwellings in these regions here. So those Peruvian fishermen normally have really good fisheries in this area because of that upwelling region that they normally experience where they live. And the water is cold. Why? Because upwellings bring cold water with it. Well, one year during Christmas, they noticed that the water was warmer. And they said they named it El Nino, like the son of God. All right. And they noticed that during that warmer year, fishing wasn't as good because if the water is warmer, that means they're not having an upwelling taking place. Okay, so that's what happened there. So what happens during El Nino? Well, there's a pressure change, and the pressure change shifts. So this used to be a high pressure, this used to be a low pressure pushing the wind in that direction. Well, now there's a shift. Pressure changes shift. So now winds start moving in different directions. They start shifting. And notice if the wind is now moving in this direction, now you have water moving in that direction. So you no longer have the upwelling in this case in the Eastern Pacific that you used to have. All right. So now you're going to have an upwelling in the Western Pacific where you didn't have one. So fishing all of a sudden might be good here for a short period of time. All right. What else happens? Well, so you know this. With an El Nino, you need to have a connection between this and the chapter on weather. So there's a little bit of weather going on in this chapter, and we have not covered that yet. Areas where you have low air pressure, you have a lot of storms. Okay, low air pressure is where you have a lot of storms naturally. So let's look at normal conditions. High pressure, low pressure. Look, areas of low pressure have rain taking place. All of a sudden during an El Nino, you don't have rain taking place where it used to. It has moved now to another area of low pressure. So you may have during an El Nino over here in Australia and in Indonesia, they might have a drought that year. They might have no rain where they normally had rain that year. So it'll shift their weather for that season or that year. Okay, so they'll have a fire season, for example. During an El Nino, it's commonly they'll have fire seasons in this area of Australia. All right, this area of Australia will have a fire season during El Nino. Why? They're used to having rain and having low pressure. Now they don't have rain and low pressure during an El Nino. The fishermen in Peru during a normal season, they have a fishery here off their coastline. During an El Nino, they lost their fishery. They don't have a fishery there anymore. What's happening now? Look, during El Nino, do we expect more rain here in San Diego? Yep, we would expect more rain because the pressure system has shifted. All right, the water in the Pacific is warmer during an El Nino because you don't have as much upwelling taking place because of the shifting wind patterns. So El Nino begins with a shift in air pressure, and that shift in air pressure moves water in a different direction, and that water now creates things that happen along the planet. So in essence, when you're asked questions about El Nino, the questions are going to relate to whether something is happening here in the Eastern Pacific or in the Western Pacific. So rain is normally expected in the Western Pacific during normal conditions, but in El Nino, nope. Good fishing during normal conditions here off the coast of Peru, bad fishing during an El Nino. Okay, so you have effects involving weather and you have effects involving fisheries and things of that nature due to El Nino conditions. All right. So goes over my explanation some more. All right. La Nina, well, it's the opposite of El Nino. Think of it as you take normal conditions and they're even more normal conditions. So it just shifts things. The pressure's even higher here and even lower there. So you're going to have even more upwelling and things of that sort. And you might have a dry year here in San Diego, for example. And by the way, these cycles, they say, are between 2 and 8 years. Here in San Diego, we hear about a lot. We'll hear about an El Nino or a La Nina year. And it's, like I said, it's generally dictated by these air pressures moving these wind patterns. Okay. Areas of the ocean, you have 3 general areas: the photic zone, the light penetrating zone, the pelagic, that's between the surface and the ocean floor, and the ocean floor is the benthic. Tide pools or intertidal zones, they're very unique. They have a lot of biodiversity. Why? And by the way, they're very harsh environments. And the reason I say they're very harsh environments, they're environments where organisms live, right? And they could be completely dry part of the day. They can be completely submerged with water other parts of the day. So these are organisms that are diverse. They can live in unique environments, tide pools, okay, or intertidal zones is what they call them. What causes the water to drop and rise? Well, it's the gravitational pull of the sun and the moon on the water on our planet. So the moon generally is the main cause of tides, but the sun is involved. When we have super high or super low tides, you got the pull of the sun and the moon compounding each other. So you'll have a very high or a very low tide when they're both lined up together and they're pulling on the water on our planet. So you got to think of the water on the planet. It's not stagnant. It's being pulled on by gravity also. Salt marshes, well, what happens is you have areas when the tides rise and fall, you have areas that are kind of flat and you'll get this pooling areas of water. All right. Salt marshes are very biodiverse. A lot of organisms live there. They're very, very, very productive habitats. High bioproductivity in these habitats. Very important for us. They're great to. We do a lot of damage to them. We generally build things on saltwater marshes and things of that sort. What do? They have a lot of ecosystem services. They filter pollutants that might be in the water. They stabilize the shorelines, and like I said, great habitats for a lot of biodiversity. Mangroves, these are pictures of them. They're these special trees with these roots that kind of dip into the water here. These are what's called an indicator species. And why are they an indicator species? Because they can detect pollute. If mangroves are not healthy, it means the water that they're sitting in is not healthy. So they're pollution detectors. These mangroves, they're getting killed at a rapid rate. And what's happening is there's a lot of fish, well, in this case, shrimp farming taking place. Specifically, shellfish or shrimp are being farmed and creating pens in these coastal waters. And that shrimp farming business is creating pollution and just taking the space that they need and all that sort. So shrimp farming is creating massive problems. And it's one of the major current destroyers of the mangrove forests on our planet. An estuary, this is where a river, basically that the river mouth, where the river meets the ocean. So this is where freshwater meets saltwater, estuaries. Also high primary productivities. These are areas where you have a lot of living things, all right? Also, salt fluctuates. As the tide changes, there's more or less salt in these areas depending on the day and the time. Kelp, these create underwater forests. These are photosynthesizers. These are algae that in our waters create a lot of habitat. They bring a lot of fish, a lot of life to these regions. So these are kelp forests, basically. And we're going to stop there today.